All right, so as we conclude 7.6, I want to go back to this question I left you off with yesterday. I think I moved this. This triangle, frozen? I'm sorry, thank you. This triangle needs to be rotated 120 degrees clockwise. So that's like to the right as the hands of the clock would move, right, clockwise. And it needs to be rotated about the blue vertex, which is the one that I have the little pin on there, okay? So clockwise, this is clockwise here. And we started the first side of this triangle here. We're rotating it about this. So this needs to be 120 degrees. Now, 90 degrees, 180, and 270 degrees are really easy on the coordinate plane because the vertical and horizontal lines make 90 degrees, 180, and 270 with those lines. So that rotation is going to be pretty easy, those ones. 120, 72, 36, that's going to be a little tricky. What you're going to need to use is your protractor, which, here it is. So the protractor is the instrument that measures angles, okay? Now I'm going to just kind of quickly and hastily draw a little protractor on the side here. So it's the half circle one, like this. And you'll have some kind of probably some kind of line near the bottom with a little X in the middle there, okay? A little cross in the middle. That's where you actually place, this is where you put the vertex of your angle. So what happens is, if you want to measure an angle, you line up one side with 0 exactly, and then you count, so, it'd be like 10, 20, 30, 40, 50, 60, 70, 80, 90 would be straight up and down. And then, 120, 30, 40, 50, 60, 70, and then 180 would be all the way around here. Okay, now if we want to do 120, so 90, 100, 10, 20. So 120 is about right here. Whoops, come on now. Right about here. So if we connected the vertex that's at the center X point and the line that goes through 120, this would be 120 degrees. Okay, that's how that would work. So what you want to do is you want to, and I'll zoom in a bit here now, with your protractor for 120 degrees, this would be the best way, I think, probably to make this most accurate, is to draw your protractor, and let me use a totally different color here. Let's use like pink. I like green. How about green? So let's put our protractor down. So right here is going to be, no, not right here. Let's put it right here. Sorry, it's going to have to be upside down on the line that we've already, that's already there. So this is where the protractor is going to be kind of like this, guy. You're going to line it up here at the center. Crosshairs right there is going to be at this blue vertex. Then you're going to count from here. This would be, 0 degrees right here. You're going to count 10, 20, 30. Well, here's 90, right? Here's 90. 110, 120. So right about here, you're going to make a little mark with your pencil. And then you're going to use a ruler or a straight edge of some sort. Once I get rid of this now protractor, you're going to use a ruler or a straight edge of some sort to connect that point that you just made at 120 with the original vertex. And then that's going to be your exact 120 degrees. So that's how you make the degrees. And now what we're going to do is measure the exact measurement. So this is 4 squares. Whatever that measurement is on your protractor, on your paper, could be 4 centimeters. It could be just 2.7 or 2.8. I don't know. So you go exactly, whatever distance this is, you'd go exactly down that distance on this. And I'm just going to ballpark it. Let me just see. Maybe I do know. Yeah, it's going to be right about here. Okay? So this is going to be your first line. So this red line that's horizontal right here matches with this black line right here. Okay? So the angle, measure the angle and the distance. And you can do that with, really with everyone, okay? Although it gets a little tougher when the vertices are not attached, right? 120 degrees. So, okay. Now we have to recreate this exact shape with the exact distances over here now. You see that? So this is the base facing towards the center of the triangle. Now this is the base facing towards the center of the triangle. So with your protractor, what you could do now is you could measure this angle right here. And that angle is going to match with this angle, you see? So I'm going to do on my protractor here. So I'm going to put my protractor on my paper, across there, try and line up that with 0. And I've got a reading of about 72? You got 71? I got about 72. So this right here, according to my paper, is about 72 degrees. So guess what? That means this needs to be 72 degrees as well. And so with your protractor, we'll get that green going again. With your protractor now, you want to line up your protractor right here. And you want to measure from 0 here all the way up to 72, which here's 90. So 72 would be about here. Okay. So you'd make a point right there, and then you'd move your protractor, and you would draw a straight line through this vertex and through this point. Okay, so I'm kind of going a long time with this, but this is kind of the best way to do this, I would say. And then you measure this distance. So what distance is that? About, let's do centimeters as opposed to the inches there. Oh, 4. Looks like exactly 4. Maybe a 4.1. 4.1. So if this is 4.1 centimeters, then this has to be 4.1 centimeters. And that's going to end up about -4.5 and +4.5. So it's going to line up about, if this line was straight, it'd be lined up about here. Okay? And then that's all you need to do, really, because now you can just connect the last dot with the first vertex, last vertex with the first vertex. And there you go. You should have your triangle looks about here. So this this point right here should be about 0 and about -1.5. So that's where this should lie. And I said this one was about -4.5, +4.5. Okay, that's where those vertices are. Okay, so any, yeah, great. Love it. Got to have a computer crash, every class here. Any questions about that now, guys? So you could do this with any angle. And if we look back to yesterday, what we had talked about was, another page before that. So the angles here, you see, if it's got order of rotational symmetry of 5, you're going to have to go 72 degrees. For that first rotation is going to have to be 72 degrees. And then all the other angles can fit with that one, and so on. So, question. Is that a hand up? Yep.
Yeah, so on here, why would we have a protractor upside down?
Why would you have it upside down? Well, again, if you want to turn your paper all the way upside down, you can have your protractor right side up. Here's the thing. If I want to copy, if I want to go in this direction, so let me zoom in again. If my rotation is clockwise, okay, and it's got to go from here clockwise, you see that? If I have my protractor facing up like this, well, then I can only measure angles up here. I can't measure down here. So that's when you flip it around and you have it upside down. If you want to turn your paper upside down and go that way, you can totally do it that way. But yeah, so the other thing, guys, is notice that you can measure angles from either side of the protractor. On your protractor, you'll have basically you'll have 0 and 180 will be the same, and then 10 and 170 will be the same. So if you go this direction, you're going from 0 all the way towards 180. So the angles will be small over here, and then they'll get to 90. But you can also, this is getting really messy, but you can also measure from here this way if you have to. And so there's also small angles over here that you can add up. All right? Okay, that is super now confusing. I've got way too many marking on there, but okay. So that's what that should look like. All right, good question though. That's a great question. If you're thinking it, I think you should ask it. But yeah, if you have your paper right side up, you're gonna have to have your protractor upside down. If you turn your paper, the other way, and you remember which way you're going, you can have your protractor facing upward. Okay, let's get to the next one to round off this lesson. This is part 2 of 7.6. So we've talked about lots about rotational symmetry. We made some snowflakes. This was my latest edition of a snowflake there, which I showed you earlier. That looks a lot better than my first one. And then option number 4 from yesterday, quite a bit better than that one too. Sorry. I won't mention any names, but anyways, glad we had a little fun with that. Okay, so rotate rectangle ABCD in the following ways. Draw and label each rotation image. Okay, as I mentioned earlier, 90 degrees, 180, and 270 are going to be really easy on the Cartesian plane because those vertical and horizontal lines make 90 degrees and 180 and 270 perfectly. So that's going to be quite a bit easier to do. So 90 degrees clockwise about vertex A, okay? About vertex A. Remember, about is the same as around. So rotating it around that point, about is sort of a more mathematical way of putting that. You see that most often in math. So vertex A is right here. So I want to rotate this whole thing, I want to rotate this 90 degrees clockwise, this way. So what does that mean? Well, that means that, and let's zoom in on this one. This is the one we're going to work on. That means that this is our pivot point, A, and this side, DA, right here, that I'm highlighting, that has to rotate exactly 90 degrees to the right, clockwise. So that one is going to become, and it's going to pivot on this point, it's going to become this one. 1, 2, 3, 4. Oh, is it 4 units? No, it's just 3 units. 1, 2, 3 units. So this one, 1, 2, 3 units this way, is now a 90 degrees from there. So this is D prime. Okay, we'll say D prime because that's the image point. This little prime symbol in coordinate geometry like this means the image point. Another image point would be D double prime, or 2 ticks. The third one would be D with 3 little ticks. Okay, that's the third image point. So that one's taken care of. Okay. Now the tricky one. So C only goes to where? What's the coordinate for C prime? You tell me. What's the coordinate? Give me the coordinate. 3, 7. Yeah, 3, 7 is going to be way up here above the screen. But if we go 7, 3, let's check it out. 2, 4, this is going to be 6, 7, 1, 2, 3. So this spot, do you think it's this spot right here? Okay. So if we were to take this distance right here, and if we were to apply it to C, then we should come to the exact same point. There you go. That's better. All right. So these connect, and this is C prime. Very good. Very good. And then where do I go? Right here. Right? The rectangle is right here like that. Okay. Awesome. So B prime is here, and A prime is right there. Great. All right, and I'll do this one maybe in green or something.
Do we do all that in the same class, or can we do them separate?
Do it on the same graph like I'm doing it. I mean, if you want to do one or something on the other graph where there's a little more room, doesn't really matter to me. It's kind of nice to see the pattern though, where you can kind of see the 90, 180, 270. It all fits together. So. So what is? So again, please write this down, everybody write this down right now, because I'm going to navigate away from this page. 4, 5, 7 to 9, 13AB, and 15.
Are we going to need graph paper?
I don't know if you'll need graph paper. You can probably just use your lined paper. You have lined paper. I mean, the vertical lines, if they mean that much to you, you can use graph paper, but you could probably just use your lined paper for... What's that? Yeah, and what I'm saying is you can just draw the X and Y axis on your regular lined paper if you want, and just use that if you want, but yeah, you can have another piece of graph paper here. I'll have enough for one more for this assignment if you want it.